Welcome to this brief video that shows the effects of magnetic interference on MWD azimuth reports. We all know that MWD surveys depend on the Earth's magnetic field as the reference direction for magnetic azimuth calculations in a survey tool. Unfortunately, we sometimes forget that magnetic interference will affect the apparent direction of the Earth's magnetic field, and the result will be errors in the reported magnetic azimuth. Most survey management practices are focused on post-job survey analysis to accurately place a completed wellbore in computer space for future anti-collision analyses. But this should remind us that we must know as accurately as possible while drilling where we really are relative to a properly surveyed and post-job managed offset wellbore survey. Real-time MWD survey corrections are only step 2 in accurately following a well plan. Step 1 is good slides based on accurate interference-corrected MWD reports. In Part 1, we will highlight several but not all real-time management issues. We begin by looking at some simulations of magnetic interference effects on MWD reports for two different hole directions with both minor and significant drill string interference. Let's review this graph in a little detail, as we will be looking at it several more times during this demonstration. This is a simulation of interference effects on a MWD survey taken in a hole having 50 degrees magnetic azimuth at 85 degrees inclination with only 100 nanoteslas drill string interference. The multiple values show the effect of random changes in V total and dip representing an unsettled period of geomagnetic activity. This is a relatively common occurrence. With no corrections, the raw surveys are centered about the nominal hole direction. The scatter is due to sensor noise that is a part of this realistic simulation. The short collar correction is shown in this demonstration is representative of one of several similar corrections that may be available to an MWD engineer. Please note that short collar corrections should be used with care because hole direction may have serious effects on the proper use of these methods. Here, the increased scatter of the short collar correction in this hole direction is caused by variations in the reference field that affect this method but do not affect the real-time azimuth method. The horizontal axis is the sometimes, but not always, useful QC parameter B-total dip. B-total dip combines the reported B-total and dip values that are pumped up by the MWD system for each survey. The real-time azimuth, or RTA correction, is a recently developed and patent applied for correction developed by Proximity Drilling Management, LLC. Drill string interference may be due to either a hot motor below the sensors or heavyweight collars above the non-mag section of the BHA. The 500 nanotesla value used here is fairly typical of what might occur with short spacing of the MWD sensors above the top of a moderately hot motor. Here, both correction methods are effective in correcting the average raw survey offset of about 1 degree. In this example, the simulated hole direction is 85 degrees magnetic azimuth with 85 degrees inclination. The scatter in the correction methods is significant, as would be expected for a hole direction close to horizontal east-west. Drilling close to horizontal east-west with 500 nanoteslas drill string interference, both corrections show significant scatter as might be expected. A comparison of these simulations indicates that you should be really careful what you assume is a good survey based on B total or dip values only. Remember that these simulations are what can be used during planning a wellbore or planning a slide during operations to determine the expected survey accuracy in congested regions. We will discuss this more in Part 2. A short survey requires the least possible rig time for a complete survey. Only the inclination and azimuth values calculated downhole and the QC parameters B total and dip are pumped up, as well as tool face. Here we are transferring these values from the previous simulation to inputs as would be received by the MWD engineer during operations. It is interesting to note that on average, the RTA correction is accurate with only 1 degree variance during this simulated unsettled period for this near horizontal easterly hole direction with significant drill string interference. Up to now, we have not seen a significant difference between the short collar method that was selected for this demonstration and the real-time azimuth method. This is because both methods are roughly equivalent when used with very accurate reference values of B total and dip. In Part 2, we will see the effects of even a small error in the published reference field as used by an MWD engineer. Thank you. There are many issues that we did not have time to discuss in this video. Questions via LinkedIn or by email are certainly welcome.